Hey everybody. In class for the last couple weeks, we've been working on solving different types of equations. We've seen a lot of different kinds, different numbers of steps, different kinds of steps. Today we're going to learn about what to do when we have a variable on both sides of the equal sign in an equation. So I have an example here, 7 minus 8x equals 4x minus 17. First thing I'm going to do is separate the two sides of my equation with a line. This is going to be really important when we're solving equations with variables on both sides, because there's going to be more steps in equations like this, and we got to make sure that we stay super organized. The first thing we want to do in an equation like this after we draw the line is to get rid of one of the variable terms. We want to eliminate one of the variable terms on either side. It doesn't matter which one we do. And we can use inverse operations to do that. Over on the left here, I see I have a negative 8x. I want to eliminate that term and get that equal to 0. So what I'm going to do is, since that says minus 8x, or it's a negative 8x, I'm going to add 8x to both sides. Negative 8x plus 8x is 0. So that eliminates that term. And if I do that to the left side, I have to do it to the right side too to make sure everything stays equal. Now I have 7 equals 12x minus 17. We just combine like terms. Negative 8 plus 8 is 0, 0x. 0 times x is 0. 4x plus 8x is 12x. And now I just have a regular two-step equation. I'm going to add 17 to both sides. That gives me 24 on the left. On the right side, those cancel out. Negative 17 plus 17 is 0. Now I have 12x. 12 times x, inverse operation is division. Divide by 12, and I have x equals 2. That's my answer. Now I have the same example over here on the right, same problem, because there's a different way we can solve it. I got rid of the negative 8x the first time we solved it. I can also eliminate the 4x if I want to do that. And since it's a positive 4x, I'm going to subtract 4x, because 4 minus 4 is 0. That will give us 0x. So if I do that over there, I also have to do it on the left side. Now I have 7, negative 8 minus 4 is negative 12x equals negative 17, right? We have these cancel here. Now, two-step equation, that's a positive 7. I'm going to subtract 7. Negative 12x equals negative 24. Now, same thing, inverse operation. You can do division. Divide by negative 12 on both sides. X equals positive 2. So you can see no matter which strategy I use, if I eliminate the negative 8x first or I eliminate the 4x first, I still get the same answer either way. Let's take a look at another little bit more complicated example. Here I have some parentheses in this problem. I'm going to start my problem the same way, drawing my line down through the equal sign. Now 9x minus 5, that looks fine over there on the left, but over here on the right I have 1/4 times 16x plus 60. A couple different ways I could solve this. I could do the distributive property, multiply both terms by 1/4, and actually that doesn't look like a bad strategy this time, because I know 1/4 times 16 is going to give me a whole number, and 1/4 times 60 is also going to give me a whole number. So we can do that. We get 9x minus 5 equals 1/4 times 16 is 4. So we have 4x, and 1/4 times 60, 1/4 of 60 is 15. Now, similar problem I had before, I can eliminate either x term. I'm going to choose 4x this time. I can subtract 4x from both sides. 9x minus 4x is 5x minus 5 equals 4 minus 4 is 0 equals 15. And now I add 5 to both sides. Negative 5 plus 5 is 0. 5x equals 20. And now I divide. X equals 4. Now, there's actually another way we could have solved this problem. There's a few other ways we could have solved this problem. But I want to look at one specific way right now. So we have 9x minus 5 equals 1/4 times 16x plus 60. So another step that we could have done to start this problem is, instead of distributing that 1/4, is we could have eliminated it before we do anything else. 1/4 is a fraction. I can multiply both sides by the reciprocal. The reciprocal of 1/4 is 4. Now, if I'm going to multiply this left side by 4, I got to put parentheses here. So on the right side, 1/4 times 4, those are both going to cancel out because 1/4 times 4 equals 1. So on the right side, I now have 16x plus 60. And on the left side, I have 4 times 9x, that's 36. 4 times negative 5 is negative 20. And I can't forget my x there, 36x minus 20. And now we can solve this problem using the same steps that we saw on the left and we saw on the previous problem. And we'll get the same answer. And if you don't believe me, feel free to try it out. Sometimes when we have a variable on both sides, some funky things can happen. So let's see some of those possibilities with these next two examples. In example A here, we have 3x equals 3 times x plus 4. We can distribute this 3 to start. Just draw my line. And I have 3x equals 3x plus 12. The next thing I want to do, since I have a variable on both sides, is eliminate one of them. I'm going to eliminate this 3x on the right. So I'm going to subtract 3x from the right, and I need to subtract 3x from the left. 3x minus 3x is going to give me 0x, but 0 times x is just 0, equals, oh, that gives me 0 too. So these cancel out also, and I'm just left with 12. Now I have 0 equals 12. Now, I don't have a variable to solve for anymore. There's nothing I can do in this problem to isolate the variable. We're done. We don't have any more steps to do, but this equation is not true. There is no value of x that exists that can make this equation true. It doesn't happen. So we say that there is no solution to this problem. 3x can never equal 3 times x plus 4. Let's check out this example on the right here and see what happens here. Sort of similar. We got 2x plus 10 equals, we got to distribute this to 2x plus 10. Now, I'm going to do the same thing. I'm going to get rid of this 2x minus 2x, and I actually see something similar is going to happen in this problem. 2 minus 2, that gives us 0. 0 plus 10 is 10. We get some cancellation there. Same thing over here, I get 10. Now, once again, there's no more variable. Our work is done. We can't do any more steps, but this equation is true. 10 is always going to equal 10. Doesn't matter what value of x we have. The left side of this equation is always going to be equal to the right side of this equation. So we say that this equation has infinitely many solutions. X can be anything, and this equation will be true. All right, that's the last of our examples for tonight. Make sure you finish the rest of your notes, and don't forget to submit them through Canvas. I'll see you guys tomorrow.